Factoring by difference of squares. So, to undo polynomial multiplication, we use different modes of factoring: greatest common factor, splitting the linear term, differences of squares, and there are other methods that we're not worrying about in Algebra 1. Factoring by difference of squares takes 3 steps. First, you identify that it's a difference of squares. You'll take the square root of each term, and then rewrite as 2 binomials. So, first, it is a difference because you see it says subtraction. T squared is a perfect square. 25 is a perfect square. So we can write it by taking the square root of t squared will be t. The square root of 25 will be 5. And one of them will be subtraction, one of them will be addition. If you don't believe me, you can always multiply them together. But the idea is that this is the same thing as splitting the linear term of 0t. You could say this is t squared plus 0t minus 25. You split the 25 into 5 and negative 5, and then you get t squared plus 5t minus 5t minus 25. So then t times t plus 5 minus 5 times t plus 5, giving you t minus 5 times t plus 5. But you don't have to do all that. Because of this structure, this always works as long as this is a perfect square. The original term was a perfect square, and this is subtraction. So that's why it says difference. That's what makes it a difference. And that these are the 2 squares of squares. So t squared plus 25, those are both squares. T squared is a perfect square. 25 is a perfect square. Plus is not a difference, so nothing to factor there. Move along. Now, 4x squared is a perfect factor. Its square root is 2x. 9 is a perfect square. Its factors are 3 and 3. So negative 3 plus 3. Here, these are both perfect squares. We have 4h is the square root of the first term. That's a negative, so good. 36, the square root of that is 9k. And it doesn't matter which one's subtraction and which one's addition, but that will work. The square root of 4 is 2. The square root of b squared is b. 2 and b. One of them is addition, one of them is subtraction. Here, the square root of x to the 4th is x squared. The square root of 4 is 2. And then put in the signs. X to the 6th is a perfect square. X to the 3rd. Again, it's subtraction, so then it's a difference of squares, good. Minus 5 plus 5. For this, the square root of that is 3y. The square root of 100z squared is 10z. And then we have minus and plus. Here, the square root of a squared, a to the 4th is a squared. The square root of b to the 6th is b cubed. We have minus and plus. Good. And this one's a little trickier. The square root of r to the 4th is r squared. The square root of 16s to the 4th is 4s squared. One of them should be minus, one of them should be plus. And now, this first polynomial factor is a difference of squares itself. So we'll keep the r squared plus 4s squared because it's not a difference, it's a sum of squares. But these are the square root of r squared is r, the square root of 4s squared is 2s. And we can use subtraction and addition, and that's our answer. Thank you.